So in this video, I want to walk through a partial example of how I would go about doing this project. Now, the first thing you need to do is to get yourself a polygon shape. Again, the minimum is going to be 6 sides. Let me just show you some possible examples. This here is a 6-sided concave hexagon. This one right here is also concave. When you see convex hexagons, that's kind of when the angle comes inward like this. So here's a couple different convex ones. Pick a shape, draw a shape that you want on your own paper, draw it on your computer screen, and then go ahead and start to analyze it. So I went ahead and I chose that first shape in the upper left-hand corner as my hexagon. Now, what you're going to have to do in the next step is get out either your own physical ruler and protractor at home or download those Chrome extensions for the online ruler and online protractor. In the previous video, I showed you how I measured these side lengths here. So I'm going to measure all the side lengths in centimeters and record them and do it to the nearest tenth of a centimeter. Mine came out nice and clean, so I didn't have any tenths on that, with the exception to these 2 lines that, because I use the online ruler, I was not able to actually measure diagonal, so remember I had to compute this diagonal length using Pythagorean's theorem. Now, the next thing you do after that is also measure the angles. That online protractor works wonderfully for it, so please use that, and measure your angles to the nearest integer. Then the next step, I need to segment the interior area of my polygon into the various triangles. And there's lots of different options. There's not a wrong way to do it. On this one, just make sure that the red lines do not overlap at any point in time. You can only go from one vertex to another vertex. So I could do this option and look at these 4 triangles. I could do these 4, this, or this one here. I'm going to go ahead and show you how I would analyze my project, and I'm going to actually choose this one in the bottom right-hand corner. So let's take a look how I would start to dissect the area computations and getting all the interior angles and interior segment lengths. So what I'm going to have to do for this entire activity is compute the 10 different angles that got created. Here, notice angle D and angle B did not get bisected at all, so you do not have to find those angles. We already know those. But all these ones marked in the yellow, there's 10 of them in my picture where I'm going to have to do the mathematics of some shape or fashion to get the angle. Even though this one here looks like it's a right angle, I don't know that. I have to use the math to prove what it is. I also have to use mathematics to find the 3 red line segments here, and math to do the area of the 4 triangles and ultimately wrap it up by finding the area of the complete polygon. So once you have your figure, you do want to label all of the vertices of your polygon so you can reference various triangles. This is actually a very important part so we know what you're particularly talking about. Now, when I first look at this, I'm going to actually go triangle to triangle, and I see this triangle here first, so I'm going to work at finding the area of this triangle. This is called triangle ABC, and I've labeled it like this as we would in geometry. To find the area of this one, it's actually nice for me. This is a right triangle, so I can actually go ahead and do the area of a right triangle, which is just 1/2 base times height. And when I put that in here, what I'm going to get is the 1/2, 6 times 4, which obviously gives me 12. And remember, this is in centimeters, so it's squared centimeters. So I do know the area of that object, which is great. However, in this project, we also have to complete all of the missing angles and line segments. So I'm just going to focus on this first triangle. I need to find this particular angle, this angle, and the red line segment. I'm going to start by finding this first angle here. Now, to label it properly, this is angle, by the way. It's going to be CAB is how you would say it. You can't call this angle A because angle A is really the larger one. So the smaller one is angle CAB, so I'm going to write that down properly and do angle CAB. Now, to find angle CAB, this is a right triangle. I'm going to choose to use my SOHCAHTOA ratios. I'm going to write the tangent of that angle. So tangent of, I guess I should technically say, write it as angle CAB again. And I'm going to do 4/6. Now, to find the measurement of that angle, so the measurement of angle CAB, to get that angle CAB out of the word tan, remember, you're going to do your inverse tan. So I'm just going to go on in here and do the tan -1 of 4/6. When you do that, you're going to get, I'm going to round this to 33.7 degrees. Now, I know when I said when you measure your angles, round to the nearest integer, yes, when we use the protractor, but in this math portion, if we round to the nearest integer, we're going to start getting bigger rounding errors. So I do recommend on the mathematics portion, go out at least 1 decimal. You could go out 2 if you wanted to, but I'll just go out 1 here. I'm going to go and actually label my picture because I like having all that information. So this is 33.7 degrees. Now, to get the other angle here, what I could do is, again, how do you say this one? It looks like it's angle C, but it's really angle ACB is how I'm going to say that. So let me write that here. I'm going to find the angle. Again, I'm going to say ACB, which is this guy here. To find it, I could use SOHCAHTOA, or I could just use a property of triangles. I know a triangle is 180, so I'm going to take 180 minus the 90 minus the 33.7 degrees, and this one comes out nice and cleanly at 56.3 degrees. So then I could label that particular angle too and have it done in my picture. The last thing for this triangle I do want to find is that side length. So this side length, I'm just going to call this is obviously side length AC in terms of the picture. So for writing here, let's find length AC as a segment as you would in geometry. Really nice way to do this is just using Pythagorean's theorem. Now for the math portion, if you don't like calling it a segment AC, if it helps you, that's fine. Come on in here. You could just call it side length X for this work. So what we could do is say X squared equals 6 squared plus 4 squared. I'm going to solve for X by taking the square root. When you do that, you're going to get that this is approximately 7.2 centimeters in length. So then I'm going to go on in over here and label this at 7.2 centimeters. Now I have that first triangle, all the components done. Keeping in mind, I do ultimately need to use this area number at my final completion when I add it up. Let's look at the next triangle. Now for the next triangle, I want to find the area of this one here. I'm choosing to call this triangle AFC. By the way, I could call it triangle ACF. Order does not matter on that. So to compute that area, one of the requirements in the project is you can only use the 1/2 base times height formula one time. You must use the 1/2 AB sine of C all the other time. And even if we wanted to use 1/2 base times height on this one, you have to be careful. Yes, I think that's a right angle, but you have to prove it mathematically because we split the 135 into 2 smaller angles. So what I'm going to do now, just to help myself to keep track of it, I'm going to write down the area formula is 1/2 AB sine of C. So basically remember, I need to find 2 different side lengths, right here A and B, and then the corresponding angle that they make. When I look at this particular triangle, what comes to mind for me, because I already have this one side length, is why don't I start by using that one? So I'm going to highlight that particular length. I'll do this in green. I'm going to use a side length 4 as one of mine. I need a second side length, so I can choose if I want this side length or if I want this one. I already have this side length, so I might as well use that one too. I'm going to have to find the other length though, just for the requirements. So I have that. Now because of that, this is the angle that I need. Well, I'm going to go ahead and actually fill in this formula a little bit already. So the area is 1/2. I have the 2 side lengths of 4 and 7.2. Well, I do need to find the sine of that particular angle that got created by that. So to find that angle, that's not going to be difficult because the one feature I do have is I know this entire angle is a right angle of 90 degrees. I can easily back into that. Now let's do the proper notation for it. This angle here, the smaller one, is angle FAC. So I'm going to write here the measurement of angle FAC. You need to show this math. It seems basic, but show me that you're doing 90 degrees minus the 33.7, which clearly is going to give us the 56.3 degrees. Okay, I'm going to add that to my picture so I have that information. And I am actually ready to go ahead and complete this portion here. So let's put the 56.3 degrees in there. And from it, we can compute a final area. It comes out to 11.98 squared centimeters for this one. So I could keep it like that. If I round it to 12, that would be okay, but I am going to keep these 2 decimals just to show that difference on it. Now, I will tell you though, in reality, this is a right angle, but it's not exactly a right angle per the math because we have a rounding error in terms of the angles, and that's fine. That's going to happen. I would not expect this to come out cleanly at exactly 12 because of the rounding error, so don't worry about it. That is the expectation. Okay, let's continue on in the triangle. We still have two other angles and a side length we have to find for this one. So if we highlight, what is still missing is I have to find this angle, and this other side length here. Again, I'm just going to call this, if you want, side length X, or really it is side length segment FC on that one. How do you want to go about doing it? Just take a look at it. I really don't have enough information. I'm trying to think of using law of sines. I don't have enough information to use law of sines yet on these two angles. You can't use SOHCAHTOA because we don't know this is a right triangle. My only option to start off with is actually to do law of cosines and find this side length X. So to do that for side length X, what I'm going to do is I need side length X and its corresponding angle is here, and I do have the other two sides. So law of cosines works perfectly for this. So I'm going to say to find side length FC, what I'm going to do is x squared equals my two sides squared, the 4 squared plus the 7.2 squared, minus 2 times the 4 times the 7.2, and it's times the cosine of that angle that corresponds with the side of 56.3 degrees. Now to solve this for x, all I need to do is take the square root. When you take the square root of this, what you're actually going to get is that it rounds to approximately 6 in length. So I'm going to label that back in the picture. This is side length equals 6. Now let's go ahead and why don't I find maybe this angle right here. This is angle AFC. So I'm just going to write that accordingly. We will say let's find the measure or angle AFC. If you look at how to do that, we don't have this angle measurement here, so I'm going to come back here. I don't have that, but it does match up with this side. Well, this is perfect for law of sines. I have this angle in this side pair, so let's do a law of sines connection for that. So I'm going to do the sine, and I'm actually going to call this angle AFC over its corresponding side of 7.2. That's going to be equal to the sine of 56.3 over the side length of 6. Now to solve this, I'm going to multiply by 7.2 on both sides and take the inverse sign. So this is going to give me, I'm going to take the sine -1 of my 7.2 times the sine of 56.3 and then divide that by 6. When you do that, what you're going to get is approximately 86.7 degrees. So remember when I said there is a rounding error. It is a rounding error, and that's fine. That is what I would expect. So don't put 90 degrees for that one if that would have been the case. I really am going to follow your math. We are almost done. I need one last angle. The angle I need to get here is going to be angle FCA. I can easily do just the property of good old angles for AFC, and so I will write this down here. FCA. So the angle FCA is just going to be my 180 degrees minus the 86.7. Sorry, it's running out of space here. Minus the 56.3. That is going to give me a 37-degree angle, and I can actually label that. And I have everything for that second triangle completed. Again, what I need to take with me for sure is the complete area of that triangle for the final component. Now, in the next two triangles that I have left, I'm not going to do all of the work on this third triangle. I'm going to let you kind of think through because I've given you lots of steps and suggestions and approaches. But for triangle FEC here, again, it's not a right triangle, plus I know I'm going to have to use the other area formula of 1/2 AB sine of C. Pick two sides and its corresponding angle. So it's up to you on that one. This is actually almost set up, so let's just talk through it quickly in terms of how you get started. I mean, I have this side length at 2.8 and I already have this side length at 6. I would say just find this angle and then you can actually complete it. So you could fill in this formula easily. You have to find angle C. You're going to have to be a little thoughtful how to find angle C because there is quite a bit of missing information so far. In this particular picture, you're going to have to find this angle, and this side length right here. So you're going to have to use some law of sines and law of cosines to go about finding the missing angles that you need and that extra side length. So you can think through how to go about completing this information. Again, law of sines and cosines will get you there. Now, if you look at this last triangle here, this one right here, I'm going to write this down. We have the area of triangle, I'm going to call it EDC. For this one, using the same formula of 1/2 AB sine of C, it's actually ready to go, so that's not going to be difficult at all. So go ahead and I would just say set up your formula for this one too, like we did before, and compute the area of that one. So this green last triangle is a quick and easy one. This third one here again, you're going to have to do a little bit more work. So then once you're done with that, you just want to bring everything together and wrap it up and give me the math that would show you how you get the complete area of this polygon. Basically, just show me that you're adding up the 4 area triangles computations and you get your final answer to the squared centimeter. And that really is the gist of the project. So make sure when you upload your work, it's going to be the image that you have and all of the supporting work. I want to make sure I can follow it easily. This is a lot of math, so if you want to color code things, you really want to label things properly like I did using your skills of geometry and how you write triangles, how you write angles, how you write line segments, so that it can be followed and you can get all of the points for that component. Now, this is day 2, is the kickoff of this. Again, the deadline is going to be at 3 p.m. on day 3. Now, for everyone, your day 3 is a slightly different. So day 3, for 4th hour, it is going to be Friday. I'm going to hold a Zoom session at the beginning of the hour. This is optional. If you want to join in at the session, it's going to start right at the beginning of the hour at 10:30 for about 10 to 15 minutes. And I'll answer any questions that you have to help you with guiding you along the way. If you want to join that, please do so. If you want to just email me, shoot me an email at landonn@277apps.org. Be careful, there's also a Landon D. That's not me. I'm not going to get that email, so be very cautious on what you type. For 3rd and 7th hour, your day 3 is that next Monday, so if you want to join in, 3rd hour, yours will start at 10:30. 7th hour, you will start at 1:45. And again, please keep in mind that your hexagon should be unique from anyone else in FST. There is no rational reason why anyone should have the same side lengths and angles. You're drawing these on your own, so there should be variations for everyone's project on here. And then make sure that you make the deadline. Again, the end of day 3 at 3 p.m. you want to have this submitted. Anything submitted after that can only earn up to 60% on the grade, so please make the deadline.